The Sporland division of Parker Hannifin Corporation is sponsoring this podcast. Sporland is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporland maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max Press to Connect, and Zoom Lock Push to Connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporland.com.
I guess that's Jim and John for Sporland signing off.
This episode is sponsored by United Refrigeration and Westermeyer Industries, revolutionizing your HVACR experience. Visit URI.com for all your HVACR needs, offering real-time inventory, personalized pricing, and a nearby stock feature. Access quick pick replacement parts and branch details effortlessly. With 350 plus fully stocked locations across North America, our knowledgeable staff are ready to assist with the solutions you need. Exclusive offer. Use code ARPOD on URI.com to get a $10 gift card when purchasing the Westermeyer Oil Float, part number W4300-38F. These high-performance floats are not just compatible with their own oil separators, but also available as a crossover model, conveniently stocked at United Refrigeration. That's code ARPOD to claim your $10 gift card. Visit URI.com now.
Jamie ever. You don't tell me what we're doing until we actually get there. Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're the host, Wetzel and Kevin Compass.
What's up?
How was your drive? You said it was long. What's going on?
It was not good.
Just realized what you said. Take 3, apparently, because I'm a retard today. Good evening, everybody, for the third time. And welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel, who apparently doesn't know what the hell he's doing tonight, with a nice Kevin Compass. So I don't know if it's going on tonight, but everything is just tossed. We just had a 10-minute conversation, and asshole wasn't recording. Awesome.
Terrible, Jamie.
Anyway. All right. Kevin had a long drive. I was in Houston. I had to put in ductwork. That basically recapped the fucking past 10 minutes that we just said. And I'm done. I'm done already. So now that we're actually recording, what are we doing?
We're going over compressor efficiency testing. And this continuously comes up.
You just feel pumped down. That's it.
The pump down is not the way to do it. So we're going to go over ways to test the efficiency of compressors, how to check them, how to use these softwares that are out there to your guys' advantage so we could properly troubleshoot and test compressor efficiencies. Now, when I say efficiencies, whether the compressor is pumping 100% as it should. Because all these boomers and old timers will tell you, just do a pump down test. Just do a pump down test. That really doesn't tell you shit. Because you could have multiple cylinders in a compressor and have a broken crank, or a broken rod, and you're not here vibrating, and you will not efficiently refrigerate the space, but it will pull into a vacuum, and it will hold. You could have a bad read on one side and not just blow all the way through, and it will hold. We're going to go over some ways to show how to test the efficiency of a compressor, to see how you could effectively see what the discharge temp should be. If you have a compressor overheating issue, you could see what your target discharge temps should be and how to more effectively troubleshoot this. Now, if Jamie has it ready,
the Copeland. I don't know what's up with the Copeland mobile app. Let's start with the Bitzer. But you said you have the software, do you not?
I have the product selection software.
We can use that if you want to go off of that, and if you think you can manage being Jamie, because you're. So I can't wait for this because you talk shit whenever I'm trying to do stuff. So this is just going to be just lovely. So if you want to start with the Bitzer one, or unless you want to do the product selection one while I'm still struggling to get this other thing up.
Let's bring the Bitzer one up. Do I have to do it?
I have it up, jerk. So
I just talked to shit. You put the things in the screen.
I'm gonna use the Microsoft Paints and do it that way because
that's literally what you do all day long. You make.
Now you're just talking shit, and that's just not cool.
I'm just kidding.
Nope, I'm done. It's done.
You're really good at it, though.
Way to placate to my ego. Go ahead. What are we doing? Are we doing so go ahead. Why don't you
do reciprocating? Why does yours look so much fancier than mine?
I don't know. This is the online one.
Oh, it looks way better. All right, bring it up.
Maybe because your computer never works.
No, this computer works fine. This is a laptop.
Anyway, so here you have your options, right? So this is where we first were, except for it doesn't have the pretty pictures. And then so you have reciprocating. That's what we're going to do. You can make it for refrigeration or heat pump. You could do compressor type, single or tandem. We're going to do single. Standard, you can either do a standard or the vari-speed. If someone doesn't know what the vari-speed is, the vari-speed is basically your VFD style pump. The vari-speed is that big gray VSD on the back of there. So we'll do standard.
It's always broken on every rack.
Not every single one. And if you didn't know, jerk, guess we're never getting that, whatever. So anyway, standard. And you can either do cooling capacity and like figure out a compressor for that, or you can do a specific model number.
Let's change it to bullets and hand grenades and not the European style.
Okay. Oh, that's right. Okay. That's in. Is it this one?
No.
Where that? Oh, it's over here. Sorry. So if you need to change it to the Murica one, you just do unit conversion. And not that one. Sorry. Do options. There we go. And we're doing English and Imperial or SI? I thought I was in SI, wasn't I?
It was in KW.
Was it really? Do options. Oh, it's because I have it in Deutschland, in the motherland, where the Zeal Albig motor comes from. Is that where they really come from? USA.
The Zeal Albig girl was interesting.
Is that you're talking about a female Brett?
Yeah.
I really still don't understand why you called her female Brett.
Okay, now we're in
Murica units.
Bullets and bald eagles.
Anyway, are we doing actually like other refrigerants, or are we doing
do the 448?
448. All right, we have 448. There we go. Single compressor.
Yep.
Okay. Is there a certain model number that you know of?
So this is one thing, guys. If you cannot find the compressor in the Bitzer app, so you need to change it from cooling capacity to compressor model. Okay. And then also you need to change it to include former types. So if you have an older Bitzer or random like model number that they don't make anymore, then it's going to be in there. They only put the newer ones in there in the first drop down. So if you can't find it, it's in there. Now, when you're entering this information, this is where it's key. Do not enter what the rack legend is for like the suction and saturated suction temp and the saturated condensing temp. You need to enter what the actual compressor is running at this time. So if it's a plus 20 design and it's running a plus 22, and if it's running an 85 degree condenser and it's sized for 115, you put the 85 in and the plus 22 in. You want to test it at what it's running right then and there. So
you hear that, Shane?
And then also suction return gas. This is extremely helpful when you're troubleshooting discharge issues. So you need to get an accurate suction return gas temp at that compressor. not the one off the rack. Just throw a probe on there and get the actual suction return line temp. Now, what this will help with, this will help you calculate discharge temperatures. So go ahead and run it, Brett.
Hold on. What saturated suction? What saturated condensing temperature?
What it has?
Fine. Why you gotta yell at me? You're so angry.
Oh, and then down here you could also change it. You can change it to
with
external
or without control. Yeah.
Yeah. So you could actually check it at different hertz of what it should have.
Yeah. So this would be the very step. So that'd be the Bitzer's digital compressor function. External, external drive. So you can hit the little thing right here. Frequency drives. Ooh, look at that. It gives you a little bit of explainer there. Then you also have stepped. So if you have unloaders on certain sections, and then we're doing the Merca version, 60 whites. And then this thing we're doing 460, yeah?
Yeah, that's fine.
Okay. Now what we're gonna do is hit the play button, calculate button. Yay, it worked. So there we go. So it says capacity steps just 100%, cooling capacity there. I don't know what differs from that, and I don't see an asterisk. Oh, here, yeah. With 65 degrees suction temperature and 0 degrees of liquid subcooling. I guess that's what that means.
Now the thing that we're honing in on, guys, is the current. So at a 20 degree saturated suction temp and I think it was 110 condensing.
120 here, 110,
yeah,
and 20 degree SSD.
So this compressor is going to draw 8.8 amps, and then with that suction temperature, we're going to be discharging 208 degrees. Okay. Now watch what happens when Brett changes the conditions.
So let's increase. Let's just say we're instead of Chicago, let's say we're running here in Texas where it's like Satan's Anus. So like we'll run it at 100. Should I just do 120? Because 125 is usually where they have the high pressure switches set for, or the EMS. So 120. We'll go back up to the play button, and we were at 8.8. And now we are running a amperage of 9.2.
So you see how we went up, guys, and it was just slightly. Now raise the.
Hold on. Before I do that, one last thing. Anything happened with the cooling capacity? I didn't take a screenshot before. I probably should have.
It went down.
It did. Yep, because the compressor basically appears smaller. Right, so here I'm going to just take a screenshot just so I can snap and compare. Blah. And then I'm just going to run it one more time back to the other one, back to the way we had it at 110 degrees. Play. And here we go. So cooling capacity 53.9 kBTU. And we were at when it was higher, 53.5. So yes, the capacity did in fact go down when we raised that head pressure up. So what do you want to mess around with? You want to mess around with
now change the suction temperature from 65 to 45 and watch what happens to the discharge temp.
Suction gas return temp?
Yep.
65 to 45. So that basically gives us about 25 degrees of the superheats, right?
Yep.
All right, see what happens. Let me just take a quick screenshot so we can compare. New. Limas.
Hit the start button.
No, I'm trying. Just being stupid. All right, now we're still at 8.8, and look, our cooling capacity actually went up because it was at 53.9, right?
Yep, and that is from lowering that suction gas. It's more dense, so the compressor is more efficient. Now, if you look down there, our efficiency went up a little bit, and then also the discharge temp dropped from 208 down to 188 degrees. So this is where like troubleshooting stuff is a huge help for like discharge temp issues. Like over the weekend, I was having issues with a Bitzer compressor, and what I thought would have been excessive discharge temps at the CO2 store, it was hitting like 230 at times, but it was right within spec of what Bitzer was calling it for it to run. Like I would have thought it was running hot, and it was right within the spec of what it should be running, within 10 degrees of what the discharge should be. That's why this is like a huge troubleshooting tool for you to go look through stuff. Now, this is what I do anytime I'm testing compressors to see what their efficiency is. Meaning, like, if you were to take the amp draw, Brett, and you raised it to a plus, say, 25 SST, left the head alone. Leave the suction alone.
No, I'm putting this back to the way it was. Okay, so what do you want me to do?
Put it to a plus 25 SST. And this is also the same theory behind floating the suction. Watch what it does to the amp draw of the compressor.
.11 amp. 25 degree SST, liquid subcooling and condenser, nothing changed. 9.9. And head temperature went down a little bit more. And why the amperage go up or down?
The amperage went up.
Hokey. 911. And then let me go back to 20 degrees saturated, because that was weird. Unless because I was going to change something else. Play. Yeah. Current went up.
Like, guys, if you drop the piston out and you didn't notice it, your amp draw would be much lower than expected. So say if it was a 4-cylinder compressor, you're going to be drawing basically just under a quarter of the amp draw that you would be drawing if you were missing a piston. So just keep that in mind, guys, as you're troubleshooting stuff, like using this to troubleshoot your discharge temps. If you have a much higher discharge temp than what it's calling for, then Brett's going to fight somebody in the background. Your discharge temps are like what they should be. Like it is crucial to use. Let's just bring in the Copeland software.
Here's your 20. And yeah, it's still within tolerance. That is the weirdest fucking thing in the world. Because, all right, we're going to the Copeland mobile app now. Because I swear to God, if that shit happens on this one, I give up refrigeration. I'm done. Totally just, there's no reason for it. I'm quitting everything. I'm quitting the podcast. This is retarded. All right, give me a model number, bub. 4D what?
4D JDR. Did anything come up, or do I need to find my phone?
Oh, is it not showing? Hold on. Jamie's all flustered now. That's the problem. Everything was going, dude. This has been an awful start. This has been an awful just everything. Oh, I know what I did. Share screen.
Stop it. We all love you.
Share screen. Oh, that's why. Because usually I do entire screen, and I didn't. So that's gonna go away. There we go. 4D JR. No, JDR what?
TSK.
There we go. R22. So we're gonna pick
medium condense load to whatever. That one.
You don't want to do. I really don't. I don't understand why they have those low condensing ones.
They're all low condensing now.
Oh yeah, because they're AWEF stuff and such. All right, so medium temp, low condensing. Good. All right, 208. Here we go. Now, when you're I gotta get rid of those people.
The fucking ads of the hop-alons.
People, yeah, that's not what I've been looking up. Totally not what I've been looking up. Maybe I have been, but that's totally not what I've been looking up. So just saying. So let me just remove the blondes. There we go. Oh, that didn't work anyway. That's all right. Fine. Good. All right. So when you're doing this, it'll give you the capacity of the compressor. It'll give you medium temp, low condensing, 448, the refrigerant, semi-hermetic, what oil you have in there, voltage, phase, and the heights. So if you want to do this whole thing where you're trying to figure out the performance, first you have to go to regular performance. And then when this comes up, if you go to rated performance, it'll give you like the staples of what it will run, right? Which unfortunately doesn't give you exactly, you can't move these numbers about, right? So you have evaporator temperature. What if you would run it at 20? What if you would run it at 0? And so on and so forth here, right? That's lame because it's not really going to help us with if we're trying to diagnose something. So here, if we go to dynamic performance right here. So let's first start off at, do the same thing. You want to do a
same exact thing. Run the same exact test.
110?
Yeah.
So typically if you have a medium temp rack, those have anywhere from a 12 to a 15 or 12 to 18 degree delta T on the condenser. I always want to say gas cooler, like from here on out for everything. But anyway, for the condenser, that's essentially 110. Then that means minus 10, that would be, or 15, that would be 95 degrees. So this would simulate a 95 degree day. Return temperature, do you want to go to reasonable one?
Leave it. Let's just run it.
All right. And then just put like the 5 degrees of the subcooling, because that's usually what we get out of the condenser. So calculate. So given those two things, go ahead, you can explain it.
So given those two things,
I gotta get rid of
our current right now is at 70.35 amps. And our BTU capacity an hour is at 216,000 BTUs. It's a big compressor.
It is.
And then if you look down below, our condenser heat rejection, they gave you the condenser heat rejection on here is 289,380. This would be the number that you would use to size a condenser. So that includes your heat of compression, and that includes your actual BTUs of your compressor. You can see it adds quite a bit of BTUs there, almost like 70,000.
And then essentially what that would be is, right, that would be what you'd have to remove in latent heat, all right? Or I'm sorry, sensible heat.
Today's episode is sponsored by the RefRushield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Sensible heat, the actual heat that's added to the compression or heat that's added to the refrigerant from the compression process. And then it's actually, like Kevin said on the other app, it's giving you the 195 degree discharge temperature. So if you would put all these numbers in there and lo and behold, this is exactly what you had, but your discharge temperature is running 240 degrees or 230, there's something probably mechanically wrong with that compressor.
Correct. Now, Brett, run it with a plus 25.
Plus 25. Okay. So I'm going to try this because sometimes when I try to do this without hitting reset, it tells me to go screw myself. I swear to God, I'm going to cry. So current amperage, that's funny. It says it should be at that parameter. What did it actually give us? Did it tell us?
Yeah, it was 70.35 amps.
Sorry, 70.35. Okay. So now we're going to hit calculate again because I should have changed it. No, I didn't. We were at 20. What did we put in it at 25?
Yep.
25. All right, look, 187 degrees now. So the temperature went down, and it should have went down because we don't have as much compression ratio. And the amperage is at 72.3.
Where were we at before?
You know what? You have a really bad short-term memory, so do I, right? 'Cause I don't remember. That's why I was taking screenshots, and I thought you were like, Who's dumb? You can't remember. Go take screenshots. Yeah, you're right. I can't. Let's move it back.
Yeah, my memories.
Yeah, like short term, I suck. I suck with short term memory loss. Yes, it did. It did go down. No, it went up. Look, 70.35.
Because you're putting more load. Think about it. It's going to go up because you're putting more of a load on it. It's doing more work.
Oh, but the thing that actually changed. Oh, yeah, okay.
Wait,
No,
we're both having a brain fart here, and we're thinking about it backwards. The whole thing we're thinking about is we're talking about the broken compressor.
No. But the compressor will load up more. That's fine. But what we're seeing is that the capacity is actually increasing.
Correct.
And that's what's actually making the compressor better. Look, so this is with the 25 degree saturated suction, right? We like both our brains are fucked today. I don't know what it is. This is I'm gonna take 4 hours to edit. I swear to God. So we have 241,000 at the 72 amps, right?
Yep.
And then we're gonna knock that back down. So pay attention this time. 20. The amperage apparently is going to go down, but the capacity of the compressor is also probably going to go the other way too. Calculate.
Yeah, scroll down.
Doesn't calculate.
Yes, the capacity went down.
Yes. And that's what it should.
Now, what me and Brett were trying to articulate in our just enamored state is the fact that if the compressor was down a piston or had a valve issue and it was running the plus 25, okay, it should be running at a 72.3 amps. Okay, if it's drawing 69 amps or like 60 amps, okay, something's wrong with the compressor. And that pump down test, that compressor would probably pass the pump down test. If the end bell's not hot, it'll probably pass that pump down test. Now, if it isn't hot, most guys will say, do the pump down test. I've been burned by it so many times that this is how I test all my compressors. And the same thing if I'm doing an EMS conversion and I'm testing capacities of the racks and I'm trying to figure out what is actually on this rack and what is not on this rack and what my capacities are at my actual capacities if I'm redoing it. Now, Brett, bring up go scroll down. This is something, the Copeland app that is nice. Scroll down.
No, I got to recalculate. We're going back over to 25, or do you want to keep it at 20?
20, it doesn't matter.
Okay. 20, blah, blah, blah. And then just give me the back to 5 degrees of subcooling.
Just hit cap. Yep. And then go scroll down all the way down. Go to full performance. No, click the PDF. No.
That's amazing.
So the PDF guys would bring up a COP chart. And if anybody's ever looked at a COP chart, it's what the COP chart is going to do is
wouldn't have issues.
Oh my God. What a COP chart is going to do is it's going to allow you to see everything on one chart. So you could actually see everything on one chart. Oh, let me try to share my screen. Because we're this all up.
It started right from the start. You
know what, though? These are the best podcasts.
I'm just going to have a lot more editing to do. Because I was also looking for the electrical stuff, like actually how to do the electrical and such.
Can you see my screen?
We can now.
Okay, so this is the Copeland product selection software.
Can you zoom in at all or no? Already in full screen?
I'm in full screen.
Okay, so you can't zoom that in. Okay, just keep going what you're doing.
This is super small.
A little bit. Your numbers on your screen, your display are just off. It's okay. Continue.
You know what? I'm not you. Okay, so Up here, this is the Copeland product selection software. So up here, you could choose your refrigerants. So if we went 448 and we put it as dew point, we're going to switch to 60 hertz. You got your voltage over here. And this is how you click on here. You click cooling capacity requirements. If you turn it on, you could tell it what cooling capacity you wanted. But we're going to go models. We're going to choose medium temp models. And we are going to scroll down. This is set up for scrolls right now. We'll just pick a ZD. Okay, this compressor, so we go to overview. It's going to show us all the documentation on this thing. And it's going to go to the selection table. So right now you have your COP charts for all these compressors. Current at 460.
Do you want to explain the numbers to the left and the right?
So I'm trying to find the settings. Hold on. Change settings.
On that app? Like as far as making it America?
It looks more America.
60 in TE. So temperature condensing is the one on the left.
Yeah,
And temperature evaporating is the one on the top.
So this is set up for current. So this is our, if you look on the, you got temperature condensing on here. So if you went to say 110 degree condensing and you were running a 20 SST, you should be at 15.35 amps. Okay. If you were running a 70 degree condensing and you were 20 degree saturated, you're going to be at 11 amps.
Okay.
Now, same thing. If you went to a 30, you're going to go up slightly at 110. Now, you could change this on here. You could change your COPs. You could look at your EER and BTUs per hour. So this is your EER. This is your how you look at your efficiency. And you get your KW, how many KW you're using an hour on there. And then also your technical data in here, how much this thing weighs. If you need to go pick it up on a roof and you need a crane, yada, yada, yada. That's all in there. And then I'm looking for
these nuts.
Oh, God, I fucking hate you right now.
I'm just trying to add to the
train wreck. Stop it. Now, the other thing you could do with this is you could actually do condensing units. So you could size the Copeland X-Line units and the Copeland Minis with it. And then you could also do components. So you get their CO2 bypass valves. You got all stuff like that. But if you go back to compressors and you go to Copeland, you get your discuses and then previous generations.
Those are all your older ones?
Yes. Trying to figure out how to change it from scrolls. Okay.
For the actual compressors?
Yeah.
I think you have to open up probably a new window, like a new run.
So file, new project. Yes. No. So we'll go refrigeration.
I don't know. 404 cooling requirements section, operating conditions. I have no idea.
Heard of. Oh, look, here's a 2B. Okay, this would be a 2B compressor. So it's like a 2D almost. So if right here, if we go to select, or if we go to tables, and this compressor at 110 degree condensing at 10 or 20 degree suction is going to draw 66 amps. So if it's not drawing 66 amps, there's your ability to be able to test it. And you could also see your mass flow numbers on here too.
Mm-hmm.
All right, I'm done with this. This app is, holy cow, there's a lot of windows.
So I was actually gonna ask you one of two things. So on the Copeland mobile app, because I'm not having luck because I was trying to do while you were trying to do what you were doing. On there should be a section where you basically can a little bit of diagnostic stuff, right?
Correct.
So if we bring up that same compressor that we were looking at before the dumpster fire, train wreck, whatever you want to call today's show, application, medium temp, low condensing. We don't know what we're doing. There we go. That one. Okay. So then we come down here. Okay. So we went to performance and dynamic performance. We can go to, I believe, diagnostics, right? So here's another thing that could potentially help you out with figuring out what's going on with it. So for example, if we go back to where we were at performance and then dynamic performance, because you need to know what it should be running, right? So 20 degrees saturated suction, 120 degrees saturated condensing temperature, evaporator, superheat. We're going to put that back to 5 degrees subcooling because I'm just being anal at this point. Let's put the running at 20 degrees suction. We want about 25 degrees of superheat, 45, yeah. Let's just do 50. Fuck it. Oh, wow. I love when that happens. Love it. Absolutely. Cool. This has been doing that every once in a while, and I don't know why. Performance, electrical, performance. So I've had that happen where if I press over too far, it yells at me. Like right now at 60. See what it's doing there? I've seen this happen before.
Return. Yeah, my phone will do it at times.
Yeah, and I don't know why it does that. I don't know if it's a glitch because it's not less than 25. Let's see what happens when I do 600. It shouldn't be doing that. Yeah. Let's just reset
all these app programmers are terrible at their jobs.
Seriously, I could make something up in Excel. I couldn't, but
ChatGPT could.
Okay. ChatGPT, can you figure out why this keeps messing up? ChatGPT, can you figure out why we couldn't get everything working tonight at all, including the recording?
Oh, right. Sometimes you'll have those on those big jobs.
Yeah, 198. So 198,000 BTUs. Yeah. Okay. So we have 36.75 amps. Great. Discharge temperature of that compressor 207. Great. But then watch when we go over to diagnostics. Right now, we plug in what we should have had. Oh, now this is going to make me think. 20 degrees saturated on 449. It's basically what, 45 pounds or something like that?
Yep. And the reason I bring up the discharge temp thing, guys, you really pay attention to is like Brett had one, for example, where a rack was just overheating, and all the compressors were cooking. And it ended up being that all the valve plates and cylinder walls were copper plated from moisture. And it was just basically destroying the compressors. Like they were just running hot as shit.
And can you get your PT chart real quick and just figure out what the discharge pressure is supposed to be for 449 at 120 degrees saturated?
Yeah.
You tell me. Yeah,
all those compressors were running hot as shit, and you were looking at them, and the amp draws were, they were pretty close, but the discharge temps were just insanely high.
They were close because basically the compressor was just dumping that pressure directly back to the suction. What is it?
What do you need discharge? It's 45 pounds, and what do you need with discharge?
Discharge pressure. Yeah, just want it close to what it is.
At 110, it's
120.
318.
Okay, sure. 318. All right, now Actual amp draw. I think it said that it should have been around, I think 28 or something like that. So let's just say it's not, and it's only running 15, right? 15 amps. And then actual voltage, it was shit. I should have took a screenshot. It was oh my God, this is awesome. Let's just keep it rolling. Calculate.
Yeah,
Nope.
it's 460.
Yeah, it definitely was a 460 then. TSK. Okay. Now, based on the current draw rated 37.8 amps, adjusted current drawn at the compressor using the actual compressor voltage 18.9, absolute difference between the actual and rated is negative 60.3. And it tells you that if it's 10% off, that's normal. If it's 10 to 15, likely a problem. 15 to 20, definitely a problem. Over 20%, shut that shit down. It's totally broken. We're at the shut the shit down. It's totally broken stage.
Yeah. This is a useful tool, especially for guys that are greener, in order to actually see. Like the Bitzer one, you're going to have to check it online. You go to Bitzer's website and you could use it online. It's a pain. Make sure you put your phone in. If you have an Android phone, make sure it's in desktop mode. It'll be a lot easier.
So it also gives you like any kind of schematics with any of these compressors. So on this one's a tree phase. So it basically shows you how it should be wired up. Let's see if I can do something with this real quick. I'll just do this little thing. And then I swear to God, if one more thing, I tell something to open up and it doesn't do it, computer gets punched today. It's just what's going to happen. Awesome. Not working again. So we're just going to open up a Word document because that'll work. Hopefully, maybe, possibly. Here we go. Control V. And I should be able to zoom it in, hopefully. Hopefully it doesn't look like a potato. So across the line start, and if you were doing part winding start, and it also gives you how to wire it up if you're doing across the line start versus the part winding start. So it gives you a lot of electrical information. Unfortunately, because of this emulator, it's not letting me zoom everything in. I'm afraid it's going to look like a potato. Yeah, we're almost at potato stage. Middle voltage will be disconnected before the motor sensors. So it basically breaks down all the particular electrical information for that particular compressor. So same thing goes if we were to look up something that has a capacitor start. It'll give you the actual capacitor that needs start capacitor, the run capacitor, what module it is. It also gives you extra components. So on some scrolls, you have a sight glass in there, and sometimes the sight glasses leak after years or even a gas change out. They actually will label all the gaskets that go with that actual particular compressor, some of the other components. I wonder if why should I close the whole app? That'll be amazing. Like, all right, here we go. Service parts. Yay. So look, we can look up the crankcase heater, electrical parts. Let's see what electrical parts come with this. So current sensor, obviously it's not shown. Electrical harness assembly. We can get the information for the crankcase heaters. Crankcase heater. Okay, we can get the mounting assembly, which is basically all the components, little donuts, probably the bolts that come with it, springs. Sight glass, there's your sight glass and sight glass seal. What service valve actually came on this compressor?
That is super useful when you're like ordering all this stuff.
Especially when you're doing a retrofit, right? Mm-hmm. Because you're like, oh, I don't know what's on there. Look, the gaskets, oil pump gasket. This is the whole gasket kit that does the whole shebang. Doing heads, you know what I mean? And sometimes, hey, let's just say I need a head gasket. You call them up and they're like, hey, head gaskets are on back order, but hey, why don't I just get the whole damn kit? Because then that'll give me everything on there, right? Or you could actually use it as a diagnostic tool as well. If you open up of what it is, right, and you find out exactly what head gasket's in there, you look at it, and then while you're taking out, you're inspecting the heads, and you see the other head gasket that's actually currently on the freaking thing, and it's not the same. So that's another way that it would be actually useful to help you out there. Also brings down the nomenclature as well. I know, unfortunately, I'd have to put in the serial number to get a little bit more information, but this way it'll give you a little bit of nomenclature of what's going on with those numbers, like what all the numbers actually mean. And the other thing you can do is you can actually go where to buy. So if I need that compressor right now, I don't know the zip code of H-Town, but so I'll just do where I live, 75009. Find wholesaler. There we go. There's the compressor we just had. Okay, find wholesaler. Better worker. Oh, there we go. United in Denton says it has one. Barsco.
What the hell's Barsco?
Barsco is like you ever hear them like Myers Supply?
No.
They're like, let's call them like the IGAs of supply houses, where these people have a couple supply houses that are predominantly in this area, right? Barsco is predominantly in Texas and Oklahoma.
So it's like a Johnstone, but not national.
No, the Johnstone is national, right? But then like all those companies, so like Myers Supply and Barsco, and there's a whole bunch of others, make up like an independent grocers supply house type supply house thing.
We only have 3 or 4 supply houses.
They can get stuff from other areas. Hell, we can even put yours in the Chicago area. What's the zip code up there?
46383.
46 what?
383.
That was way too fast for me. Way too fast. Fine wholesaler. But get your stuff from United because United has everything. You should have it all the time. Okay. What the hell is an Illico?
Illico is the primary supply house in Chicago.
Really?
Yeah.
Gustav A. Larson?
Yep.
Okay. But as you can see, you can actually look up that stuff. And if they don't have that compressor, we can do an old cross-reference here. Oh, and then there's your dimensions for stuff. So, like I said, Copeland mobile app has a whole bunch of biddies on there. So can you show me on the Bitzer app? Because when I was working with the other guy, we were trying to figure out where the actual COP chart is. And I was just having a hellacious time trying to figure that out.
So you got to download it, and I don't think it works on the web one. So if you go to...
So if I hit play, so you can actually download a report.
Yep.
And this will actually make a report on everything that comes with it. I'm just going to add all these things. I'm going to make a file.
Your work computer is going to tell you it's a virus.
Is it really?
And you're going to need a clearance to open it from your boss.
You'll have those on those big jobs. Okay, so there's your cover, output data, project survey. So let's go there first. All right, so it's just that compressor, blah, blah, blah. There's all your information. So there's your model number, what the compressor is made for, what refrigerant, dew point, what saturated suction, saturated condensing temperature. And this is where a good time to check all your information, and probably even better to actually do like a comparative analysis, right? Power supply, capacity control, what we're using. There's your application limits chart here. There's also your dimensions. What's this? Oil type, basically telling you what oil to run if you have what refrigerant in there, right? Let's see what else we got. Displacement, bore, stroke, which is probably something I'm going to have in the near future.
You got to put it in tables. So I just did it on mine.
So get out of this and put it back in.
Get out of that.
Okay, so go down to there. Okay, so we're here. Where am I going?
So the top of mine has something called tables.
Information, documents.
I don't know if the online version has it, because if you look at mine...
Share your screen real quick. Stop share. Edit stage. There you go.
So if we go into here, and I just click some bullshit compressor that I never even heard of anything for. They click there, whatever. Okay, if you come up here and you got reports and you have tables. And if you come up to tables, you got to give it a start value of 40.
I don't see it. I don't see it doing anything.
God.
I see just the Bitzer app. Show your entire screen, sir. Not just the window. How's that feel?
I'm exhausted and I hate this computer.
To be fair, you hate all computers because you say that at all computers.
Is it sharing now? Do you see it now?
I see white. It's all whited out and such. That's whatever you had up there. It was showing white. That is all.
Better? Sharing? See anything?
There we go. Add a stage. There we go. It's there. You just exit out. Why'd you exit out?
Because it wasn't working.
You just had it up. I just saw it. It was started working. Put it back up.
Okay. So for the last time, if we pick this stupid 448 compressor and you go through here and you hit this tables button, okay, it's going to bring up.
It's not. Did you hit entire? Did you do entire screen?
Yes.
All right, here. Stop sharing and then try it again. One last time.
Stupid screen.
There we go. I think it's up now.
Okay. So if you come on here, you go to this tables button.
Okay, tables button.
Tables button. Start value. Okay, you're going to start it, we'll say 10 degrees. And it'll step 5 degrees. Okay, and you're going to start your condensing at, we'll say 60 degrees. And it's going to stop at 105. What in the
What? What did you do to it now?
Won't do anything. Oh, God.
This is the second worst podcast I think we've ever done.
Stop it. There's some savable things in this.
No, there's tons of savable stuff with lots of editing. So it's right now it's at an hour. And I think maybe we could probably get it back down to about 30 minutes.
30 minutes is fine. All right, just stop it. Thanks, guys. This today.
What do you mean? Did we actually show what we intended to do? Or are we both so tired that we didn't really?
We went off the rails, but yeah, we got the point across.
I got nothing. I got absolutely nothing.
Push the end button, Jamie.
Everybody have a great night, guys. Bye.
Hey, y'all. My name is Paul Gross. Just want to give a shout out to the refrigeration community. Hanging out with my man Brett here.
What's going on, guys?
Mr. Brett, I think it's awesome what he's doing, bringing all of us together, as nobody really knows what we actually do in the field and what we sacrifice. So, again, just want to say hey and keep on trucking in that field. Thanks, y'all.